All right, now we're on the second page here. We're trying to solve for areas of non-right triangles and parallelograms. Okay, this is find the area of a regular hexagon with sides lengths 12 centimeters. So the first thing I'm going to do is I'm going to draw my hexagon the best way I can. It means it has 6 sides. And the thing that's useful is that if it's a regular hexagon, then all of these triangles are equilateral. So that means that each side is going to have a length of 12. So I'm just going to draw one of these triangles a little bigger. Okay. So if that's 12, this is 12, this one's also 12, right? Now, also these angles are the same measurement. All the angles in a triangle add to 180. So that means this angle here is going to have to be 60 degrees. So the area of this triangle is going to be 1/2 12 times 12 sine 60, and you put that into your calculator, and the area of the triangle is 62.354 centimeters squared. Okay, that's the area of one triangle. Now there's 6 triangles, so the area of the hexagon, we're going to multiply that times 6, and we get the area of the hexagon is 374 centimeters squared. It's very important that you write your units here. Okay. You might want to hit pause and check your work. Okay. So next question, you have a rhombus and you have the area, and you know that one of the angles is 63. Find the lengths of its sides. Okay, so rhombus means 4 sides are the same length. Okay, and one of the angles is 63. I'm going to draw a dotted line here. And so if I know that angle is 63, then these yellow sides I can label as X. And we've got our included angle, which is 63, so we can say the area of the rhombus is equal to 2, because there's 2 of these triangles, right? And 1/2 X times X sine 63. So in the parentheses here is my area of the triangle, 1/2 this side times this side, sine of the included angle. Now I multiplied it by 2 because we have 2 triangles that make the rhombus. So of course we can cancel that out. And they've told you that the area is 50. So I can say 50 equals X times X is X squared, and we have sine 63. Okay. Divide both sides by sine 63, I get X squared equals 50 divided by sine 63, and then I end up with X squared equals 56.1163. Now to solve for X, which is the length of a side, I'm going to take the square root, so X equals the square root of 56.1163, and you get the measurement is equal to 7.49 centimeters. Please put units so it will help you understand what's going on. Please make sure you write your work carefully, because if you write really messy, you're not going to understand what it is you did. And please draw careful pictures. You may want to also use highlighters like I'm using them. Okay, so regular pentagon is here, and we've got the symmetry 0, and we've got an area. Find the distance from O to A. So, so we want to find this distance right there. Now, all of these lines here are the same measurement. So if we're trying to figure out this distance, I'm going to call that x. I'm going to call that x. Okay. Now, you might be thinking, well, what is this angle? Right? So this is called the central angle. And you should have learned that in your geometry class. And to find the central angle, we can do 360 divided by 5, which is the number of sides, and then we get the central angle is 72 degrees. Okay, so this angle here is 72 degrees. Okay, so now that I've got the central angle, I can find the area of this triangle. So the area of the triangle is equal to 1/2 x times sine of 72. Okay, and now before I can do that, we know that the area of the pentagon is this. So now how many triangles are there? There's 5 triangles. So the area of a triangle is going to be equal to the area of the pentagon, 338, divided by the number of triangles, which is 5. And so that's going to give me 67.6 meters squared. So that's the area of a triangle. So I'm going to replace this here with 67.6 meters squared. Okay. We have 1/2 x squared and then sine of 72. Okay, so if we're trying to solve for x, I can multiply both sides by 2. So if I multiply both sides by 2, then that's going to make the 1/2 cancel out, and I'm going to divide both sides by sine 72. And so then I've canceled out the 1/2 by multiplying both sides by 2. I've canceled out the sine 72 by dividing both sides by sine 72. And then I'm left with x squared. If I type all this into my calculator, I get x squared equals 2 times this divided by sine 72 gives me 142 meters. Okay, so now to solve for x, I do the square root of 142 meters, and I get 11.9 meters. Make sure you write this carefully in a way that's easy for you to follow and understand when you do this later. Okay, so last part of this page, if you plug into your calculator sine of 30, 60, all this stuff, you get these values here. And the important thing to notice is, look, the values here and here are the same. And what is happening here is, remember, we're using sine to calculate the height of our triangle. So regardless if my height, if I'm using sine of 60 or sine of 120, the height of my triangle is going to be the same, regardless if it's an acute triangle or if it's an obtuse triangle. So if it's an acute triangle, then this would be the angle that we're using between our two sides. If we're using this obtuse triangle, then this would be the angle that we're working with. Okay, and sine is helping us find this height, and sine is helping us find this height for the obtuse. We'll talk more about this on the next page. But basically, sine of whatever angle is going to give us the same value as sine of 180 minus that angle. This is important to write down.